Satveli. This presentation is a part of CS259 Advanced Parallel Processing course, and I'd like to thank our Professor Robert Chen for giving me this opportunity. So, our topic for today is Apple M1 chip, a new era in computing and its future implications. So, before we start, I just want to give a brief introduction of our topic and what did we do in our project. So, the Mac and especially the MacBook series was straining to make the most of the Intel's hardware. And for years, Apple consumers have complained that Intel powered Macs run too hot or run too loud and perform poorly in demanding workloads. The revolutionary introduction of the M1 chip fixes all those problems. And today in our project, we're going to describe about the explore the capabilities of the Apple M1 chip and focus on the radical change it brought to the new era of computing. We also analyze and compare the performance of the M1 chips with respect to that of traditional Intel and other chips. So let's get started. So we have the table of contents here. So we'll start with the introduction and we'll just go through the launch of the M1 chip and compare the architecture of the M1 with respect to the previous chips and compare other functionalities of Apple M1 chip versus Intel, and we'll go through a few technical specifications like the performance, the hardware, the software compatibility, and then the conclusion. All right. So before we begin, I'd like to just start with this quote, which says, "Any sufficiently advanced technology is indistinguishable from magic." So this quote, I just wanted to add it because the M1 chip has been praised for its performance and efficiency, and it has been described as a breakthrough in computer technology. Uh, and this is a result of years of research and development by Apple's engineers who have pushed the boundaries of what is possible in a computer chip design. They created this chip that is incredibly powerful, yet efficient and compact enough to fit inside a computer. Now let's get started and then we'll just go through each of these. So we'll just start with the background of Intel chips, the introduction. So the Intel chips were started in 2005, where it had a transition from the PowerPC processors. So Apple moved to Intel processors, which allowed developers to create software for both Mac as well as PC platforms. So this move to Intel processors was significant for Apple as it allowed company to use the same processors as majority of other PC manufacturers. But over time, Apple faced challenges with the performance and energy efficiency of Intel processors. And these issues led the company to look for an alternative solution that could deliver better performance and energy efficiency. And this search ultimately led to the development of the so-called Apple M1 chip, which is the first ARM-based chip developed by Apple. And the adoption of this M1 chip is a significant step for Apple and could have far-reaching implications for the future of computing. And with the M1's chip, improved performance and energy efficiency, users can expect to see faster and more capable Mac computers while also enjoying longer battery life. All right. So let's get to know a bit more about the M1 chip. So the M1 chip is the first ARM-based chip developed by Apple, and it is designed to be used in their MacBook Air, Pro, and Mac Mini models. This chip is built on a 5 nanometer processor and features a 8-core CPU, an 8-core GPU, and a 16-core neutral engine. These features give the M1 chip exceptional performance capabilities, energy efficiency, and compatibility. The 8-core CPU offers a massive and efficient design, which means that 4 of these cores are used for performance and the others are used for only demanding activities while the other four are designed for efficiency and used for most other tasks. The M1 chip's performance capabilities are significant. The chip is capable of running complex applications with ease, and it offers a 3.5 times boost in CPU performance and a 6 times boost in GPU performance compared to the other previous Mac models. This performance boost is especially noticeable when running intensive applications such as video editing and other complex tasks. Next, we'll just go through the M1 architecture. Yeah. So here we have architecture image which explains the all the M1 capabilities. And the Apple M1 chip features four powerful Firestorm processing cores for high performance tasks. And I was previously mentioning that the other four are called the smaller Ice Storm cores for energy efficiency. And this architecture may be seem familiar for most of you, and because it has been used in ARM chip designs used in Android phones since 2004. And this particular thing is actually called ARM Big Little by ARM. And the M1's chip GPU has 8 cores and takes up only slightly more space than the process 8 cores. And but then the only disadvantage that I found while going through the research is that um, M1 chip, for now it is only available with 8 or 16 GB RAM. While most users may not be needing 8 or 16 GB of RAM on a MacBook Air or Pro, MacBook certain there could be certain enthusiasts which may be disappointed with a 16 GB machine. Um, so manufacturers can upgrade their product lines by swapping RAM chips with higher capacity chips such as 16 GB chips or instead of two 8 GB chips. So this silicon on chip built-in RAM would necessitate the double the amount of memory in the chip case. That is a redesigned M1 chip. Uh, Next, we'll just go through the ARM architecture workflow. So here in the M1 chip, Apple uses a modified version of the ARM architecture known as the ARM64. The ARM64 architecture is a 64-bit instruction set and supports larger memory addressing capabilities. Um, the ARM machine here is a family of the reduced instruction set computing, which is the RISC processors that are widely used in mobile devices and such as smartphones and tablets. The ARM architecture is designed to be energy efficient and low cost, making it ideal for portable devices that rely on battery power. And coming to explain more about the architecture, it uses a load store model for data access, where the data is stored in memory and loaded into registers for processing. And ARM processors uh, typically have a small set of general purpose registers and use a register based calling convention for function calls. This means that the arguments that are passed through registers rather than being pushed into a stack like x86 architecture. And the ARM architecture also uses a conditional execution feature which allows instructions to be executed conditionally based on the result of previous instruction. So this can reduce the number of instructions needed to perform a task. And one of the other important aspects of the ARM processor is the use of their coprocessors, which are additional processing units that can be used to offload specific tasks from the main processor. So this was about the ARM architecture, and the next we'll look how the initial x86 architecture have been designed. So in the M1 chip, Apple uses a modified version of the x86 architecture known as Rosetta 2. Rosetta 2 is a transitional layer that allows M1 Macs to run applications designed for x86 processors. It translates the x86 instructions into ARM instructions in real time, which allows Mac instructions to run applications designed for older Macs. And as I was previously mentioning, the ARM architecture is from a family of RISC processor, which is reduced instruction set, whereas here x86 is a part of CISC, which is a complex instruction set computing, and these processors are mostly used in high performance computing and desktops. The x86 architecture uses a registry based model for data access, where the data can be stored in both registers and memory. Also, the x86 processors typically have larger set of general purpose registers compared to ARM. This means that arguments are pushed onto the stacks and accessed using stack pointers. The x86 architecture also uses microcode, which is a layer of software that interprets complex instructions and breaks them down into simple micro operations that can be executed by the hardware. This makes x86 more flexible than other things. All right. Next, we can just go through a comparison of what an ARM and x86 architectures are. ARM and x86 architectures have different strengths and weaknesses and are often used in for different types of applications. Like ARM processors are more energy efficient and cost effective, making them ideal for portable devices and embedded systems. Whereas x86 architecture, it has processors that are more powerful and flexible, making them ideal for desktop and server applications that require high performance and advanced functionality. And if you would like to look in terms of the instruction set architecture, ARM uses a load store model for the data access, where x86 uses a register memory model. And ARM processors have a smaller set of general purpose registers and use a register based calling convention, whereas x86 processors have a large set of registers and use a stack based calling convention. Also, as I was previously mentioning, ARM uses the core processors to offload specific tasks, while x86 processors use microcode to interpret complex instructions and vector processing to process multiple data elements that could be run in parallel. So now that we've seen the ARM and the x86 architecture, we'll now go through a few of the technical specifications for each of the uh, M1 chip as well as the previous Intel chips. The M1 chip has proven to be highly competitive with the Intel's best performing CPUs, outperforming many of them in both single core and multi core tests. Additionally, the real world productivity tasks such as video editing, photo processing, and web browsing have shown significant performance gains on M1 powered machines. And not to miss this out, it is also worth noting that Apple's M1 chip performance advantage is not universal, and there are certain tasks for which Intel based processors still hold an edge. For example, highly specialized software applications may not yet be optimized for the ARM architecture, resulting in slower performance on M1 powered machines. However, as more developers release ARM optimized version of the software, the M1 advantages are likely to become even more pronounced. And to my left is performance comparison where it performs of the M1 chip as when compared with the latest PC chip. So it's we can see that the M1 chip outperforms and up to 2 times faster CPU performance and almost matches peak performance using 25% of the power. So this is one of the greatest achievements using Max M1 chip. And next, we can consider the battery life. Uh, the Intel CPU prioritizes performance over energy efficiency and resulting in lower battery life. and Intel CPUs have long been known for their high performance consumption. This is largely due to their architecture, which prioritizes performance over energy efficiency, as I was previously mentioning. But whereas the newer Intel processors have made significant improvements in power processing, and they still can't match the impressive battery life of the M1 chips in Apple's storage. The M1 chip, on the other hand, was specifically designed with energy efficiency in mind. Its integration of various system components, including the GPU, CPU, and RAM, onto a single chip, allows for more efficient communication between these components. The MacBook Air, for example, lasts up to 18 hours of battery life on a single charge, whereas MacBook Pro can last up to 20 hours. So this is a significant improvement in terms of battery life when compared with the traditional M1 Intel chips. So this not only provides greater convenience for users who need not worry about constantly charging their devices for greater productivity and flexibility. And next, we can go through the hardware selection. So, Intel and Apple M1 differ significantly in terms of hardware selections. Intel-based processors uh, provides users with a wide range of choices in terms of hardware such as CPU, GPU, RAM, and storage. And customers can select from a variety of CPUs manufactured from different vendors such as Intel, AMD, or Qualcomm, and based on their performance or other parameters. Similarly, users can also select the GPU according to their needs and can uh, opt for a discrete GPU or an integrated one. Um, Whereas in contrast, Apple M1 comes with a fixed set of hardware configurations, and users cannot select the CPU, GPU, RAM separately. The M1 chip is designed to be an all-in-one solution for the all kinds of Mac products, and Apple provides two versions of the M1 chip with different numbers of CPU and GPU cores, and the users can select between the 8 GB and 16 GB of unified memory and corresponding SSD, which is a solid state storage. So it offers a flexibility of selecting hardware according to the specific needs. And next, we'll see about the software compatibility as well. So when it comes to the software compatibility, the based Macs have an advantage over the M1 based Macs. The reason being, the later uses a new architecture which is incompatible to the old software. So to make this up, Apple has introduced Rosetta 2, a transitional layer that allows M1 based Macs to run software designs for x86 architecture. But while Rosetta 2 works well for most applications, it can lead to a loss of performance in some cases. Furthermore, not all the software developers have updated their applications to run natively on the M1 chip, leading to potentially compatibility issues. Whereas on the other hand, Intel-based Macs can run Mac OS software without any compatibility issues. But however, as time goes on, more and more software developers are upgrading their applications to run natively on the M1 chip, and Apple is pushing developers to develop software that can take advantage of the M1's unique chip architecture and which can lead to innovative applications. All right. So to conclude with, the Apple M1 chip is just the beginning of a new era in computing, and as Apple continues to innovate and push the boundaries of what is possible, we can expect to see even more powerful and efficient chips in the future. One future implication of the M1 chip is its impact on the use of ARM-based processors in the computing industry, and the M1 chip has opened all new possibilities for the use of uh, ARM-based processors in the future. Another future implication of the M1 chip is its impact on the development of machine learning algorithms. The chip's 16-core neutral engine accelerates machine learning tasks and enhances the performance of Apple's core ML framework. As machine learning becomes prevalent in various industries, the M1 chip capabilities will become increasingly important. Finally, the Apple M1 chip is a game changer in the world of computing, and its impressive performance, energy efficiency, and compatibility have set a new standard for what is possible in the computing industry. As we look to the future, we can expect to see even more powerful and efficient chips that will continue to push the boundaries of what is possible in this world of computing. And thank you so much. So,